All right, let's take a look at example 4. Now, what I would say to you is this. For this kind of graphing, I would say construct a little table, even though they don't ask you for the table, because that would really alleviate your workload from coming up with all these values. So always ask yourself, what are some easy numbers to start? Okay, I would say for numbers like this, it's going to be easy to think about 1, 0, 1, and 2. Okay, because I know what 3 to the 0 power is. Do you know what 3 to the 0 power? What's 3 to the 0 power? It's 1, right? And 1 minus 1 is 0. So we actually have a point as 0, 0. All right. What's 3 to the first power? It's 3. 3 minus 1 is 2. So we know there's a point at 1, 2. And what about 3 squared? It's 9. 9 minus 1 is 8. So we have this. Now, what about the other side? Okay, what about to the left? Now, if you look at this minus 1, it means it moves which direction? Moves down by 1 unit, right? So that means our horizontal asymptote, which is supposed to be the x-axis, is now y equals to -1. Now you may come up with a negative x value, say x equals to -1. So 3 to the -1 power minus 1, it's equal to 1/3 minus 1, which is -2/3. So you may put a point right here. But if you know where your horizontal asymptote is, you can pretty much make a graph that leans closer and closer to the asymptote. Okay. So the transformation is very simple. There's only one transformation, which is to go down by 1 unit. The domain would be 0 to, no, sorry, my bad. The domain, it's all real numbers. So from -infinity to infinity. And the range in this case, it's not 0 to infinity because we have a transformation of going down 1 unit. So we actually have the values from -1 to infinity.
For the table, how do you get 4 when x is 0, y?
When x is 0, so 3 to the 0 power minus 1, right? What's 3 to the 0 power? No, 1. Anything to the 0 power, it's 1. 1 minus 1 is 0.
That would be a growth.
And this would be a growth, yes. Okay, it's growing, it's going higher and higher, so it's a growth.